is one of those, like we're kind of trying to cheat the difference quotient, so we don't have to do that. That is actually, wait, so the limit is h approaches 0 of fx plus h minus fx over h. This tells you, this is saying final derivative. Your job is to say, okay, I know that based on the setup, the original equation is that. So like fx on the right hand corner, that's what being subtracted in the difference quotient. So what they are wanting you to do is say, well, that means I know that's f of x, so then f prime of x, so the derivative of ln of x is 1 over x, and then plug in 3 and get c. So that's one of those, like, can you kind of parse it out of the limit? The next one's like that too. Should I talk about that one? So the next one's the same thing, except they put the number in it this time instead of an x. But you could imagine this like it was cosine of x plus, yeah, cosine of x plus h minus cosine of x over h. If I write it that way, that tells me that's the original function. So y equals cosine of x. So again, that upper right hand corner is where the original function is. And then what's the derivative of cosine? Negative psi x starts with c. And then you're supposed to plug in a value. What value do you think we're plugging in? It's the pi over 6. So my job is to find the negative sign of pi over 6. Pi over 6, pi is 180. Pi over 6 is 30. 30 is like one notch up. So your y value goes up one notch, that's 1/2. That makes sense what I'm saying there. And that's negative, so because of that. So it's going to be t. Is that okay? You want me to keep rocking? I can do 20. I'm on a roll. Well, you tell me then. Before I just tell you. So they're telling me f of x is sine of x. This setup just means find the derivative. Like that limit function was designed to help you find derivatives before you knew how to actually find derivatives. So this time I don't even have to pick it out of the thing. I just have to look there. Understand that means find the derivative. So what's the derivative of sine of x? Cosine of x, and then we're supposed to plug in a number, which is going to be pi. So we're finding the cosine of pi. Pi is 180, which is over there. And the xi over there is negative 1. Shut up with your logical answers that make it my fault. What? For 20? That's not one. Yeah. Oh my. I didn't even know. Wow, I would have got that one wrong in the AP test. That is. This is one of those. Like this difference quotient stuff. I think I've gotten more questions on this than like anything else. There might be one of these on like every 3 AP tests. Like it's not something I want you to stress out and worry about. I didn't notice that these are actually flips, so then that changes the direction of it. So this will be positive. That's why I would have got that wrong. But I don't want to spend more time. I don't want that to be like that's like this much important. So don't like overly stress on it. That won't even be in your game. Like, I would not put one of those in your game. Because I don't know that. Other ones. Besides these stupid. let's go to 8s. Product rule will be all over your test, your AP test, your gateway. This May is going to start a gateway, so pre-calc's going to have a gateway next year, or this year. Alright, before I get here, I want to convince you that the product rule actually works. So let's say I have y equals x squared plus 1 times 3x plus 4. I just made up a random 2 things being multiplied. Well, if I were to take the derivative of that at this point, I don't know product rule, so I'm just going to FOIL, and then I'll take the derivative of it one term at a time. So that's 3x squared. 3x in third plus 4x squared plus 3x. There's another eyebrow. Looks like Jason. Plus 4. And that's just simplifying it, right? So that's still your y. And then y prime. So 9x squared plus 8x plus 3. Do you agree with that? That's just there's no special rule. Just multiply it through. So for this problem, you actually wouldn't need the product. I wouldn't use the product rule in this situation. So this section is a little bit weird because we're learning product rule, but you don't really need it until we learn chain rule. So you're kind of pre-learning. We'll use it, but it's not necessary to use it. So you're just kind of practicing it in situations where you don't really need it, so that you can do it when we do get to the part where you do need it. But if I were going to do this in product, what I would do is say, okay, this is my, I'm not going to use that function. This is my first function. That's my second function. You can call it f and g if you want. I think the rule is easier to remember with numbers. Just make sure you realize that's not a number in the actual. What the heck? I pressed one thing. What was it? 9x squared plus 8x plus 3? It was x squared plus 1, 3x plus 4? Right. Or touch the screen. That's the first thing. That's the second thing. The product rule is 2d1 plus 1d2. D means derivative. So the product rule is, this is the second thing. I literally just write that down. That's my 2. D1 is the derivative of the first thing. So what's D1? 2x, right? So that's the derivative of this. And then we just flip it. So then it's 1d2. So the 1, I'm literally just writing down the first thing. This is the 1. And this is going to be d2. So what's the derivative of the second piece? It's just 3, isn't it? So that's product rule. And I'm just trying to convince you that using this rule will still get us the same answer. Again, this is long. I wouldn't do this if you had a choice. Right now you don't. Too bad. So if we distribute, that's 6x squared plus 8x plus 3x squared plus 3, and then if you combine those two, does that convince you that it works? You get the same thing? So I just want you to realize that it matches. Problem is, this won't happen today, but if I give you that, this one. Let's say it was that. If you don't have product rule and chain rule, you gotta do both. But if you don't have product rule, you would have to do 4x plus 4 to the 5th power. So 4x plus 4 times 4x plus 4. We do try to. That's 2. Multiply this shorter, get there, it just doesn't. Today you're gonna be like, this is longer, this is stupid. But it's not. We're just preparing for a situation where it's not stupid. That makes sense. Alright, go back to the notes page if I fill those in. So they use F and G, I was doing 1 and 2. If you're using F and G, I would say G times F prime plus F times G prime. And so here's another little bit, like the order of that doesn't really matter, right? It's addition. I could flip it. But the next rule we're learning is quotient rule. And if you do it, a quotient rule is G times F prime minus F times G prime. So yes, the order doesn't matter here, but if you keep this order that I showed you, it'll be the same order for product rule and quotient rule, which makes it easy. If you want to rewrite it as like h of x equals 1 times 2, I mean, realize that's obviously not like just 1 times 2, the answer is 2. It's like the first thing and the second thing. So this is what I'll say all the time is 2d1 plus 1d2. So it's the second thing times the derivative of the first thing plus the first thing times the derivative of the second. Some people like the letters, some people like the numbers. It's kind of up to you. I will talk through with the numbers, but you can hear it however you want to. So if I'm doing number 1 here, that's my first function, or my f if you're looking at it that way. That's my second function, or my g if I'm looking at it that way. Let's see if this is okay. I do want to show you this. So a lot of people, when they see this problem, will be like, oh, I learned product rule in class, I know it exists, but I'm going to choose to completely forget about it. Let's see if that works. So a lot of people will be like, well, the derivative of that's 2x. The derivative of that's 3, so if I multiply those two together, I should get the right answer. Did it work? Like we're supposed to get that, right? So if there's two functions being multiplied together, like a thing with an x and another thing with an x and they're multiplied, it's not optional, you have to use it. So if two things are multiplied, that's a product, you have to use the product. So going back to 8x inside of x, that's my first thing, second thing. So 2d1 plus 1d2. The second thing inside of x times the derivative of the first thing, so the derivative of 8x, which is 8. Second times derivative of first. Then we flip it, so then it's first times derivative of second. So the first thing is 8x. And the derivative of the second, so what's the derivative of sine? Positive cosine. And that's your answer. What we will start doing down the road, so for your response, that's totally fine. But we'll start doing down the road, because we'll take this and like 10 steps after it, is factor out whatever we can. So is there something that, so I have two terms, one there and one there. Is there anything that I can factor out of both and reverse distribute? There's 8. So I could take that 8 out. And this would just be like x cosine of x. And one reason we might do that is you might eventually have to set this equal to 0, and now you've got like your pieces that you can work with. Another reason you might do that is just to match up with their multiple choice answer, where you end up here, but they put this, and you just gotta know they're the same thing. Question on 1? Second guy. So first of all, I'll kind of rewrite this one to say 2e to the x times x to the 1/2. The radical, like this, I don't take derivatives of radicals. It's easier if you show the exponent and then I go from there. So then you got your 2. This is a function of x. Call that 1. This is a function of x. They're being multiplied together. Call that 2, and I have to use product. It's not like do it if you want to. So I'm doing the second thing times the derivative of the first thing. So the second thing is x to the 1/2. first thing. So the first thing is 2e to the x. So that 2 is a constant in front, so what happens to the 2? It just drops down, and then what's the derivative of e to the x? Z to the x. So that's the second thing times the derivative of the first thing. I know this looks like it is the first thing. It is, but it's also the derivative of the first thing. So that's 2 d1 plus 1 times d2. So that's the derivative of x to the 1/2. Which means bring down the 1/2 multiplied by the number in front. So 1/2 times 1. Leave the x and reduce the power by 1. Now let's just stop there. I can take out a 2e to the x if I wanted to. Really more worried about that mechanics. Question on 2. Try 3 if you haven't already. I like these tables. Again, I'll probably rewrite first. So that's like x to the -1. Okay. So 2d1, so the second thing times the derivative of the first thing, which is a little bit annoying. So that's -1. Rewrite the x, reduce the power by 1. And the derivative of the 1 is just 0, so that part goes away. So that's my 2 and my d1 plus 1. Just rewrite the first thing. Times the derivative of the second thing, so times 4x. And then we'll get into like when I want you to simplify and how I want you to simplify at some point. But right now, like I said, I'm just worried about the mechanics. So if he gets there, I'm happy he gets there. Question on that? Alright, I want to do the table, and then I want to do one of the like AP questions I have. Get that home. So if I do one of the tables, I like these better because you don't have to worry about simplifying. It's usually less writing. So they give me h of x is 3 times this stuff. So first of all, I would rewrite that like 3, pull out the 3. And then we'll do product rule with the f and the g. It's possible to do that as your first thing and that as your second thing and like include the 3 in the first thing. It works, but people seem to get really confused when I do that. So it's not what I recommend. So I'm going to do product rule here. So the 3 just kind of hangs out. I'm doing 2d1 plus 1d2. So the second thing is g of x. d1 is the derivative of the first thing. So how do I write the derivative of f of x? It's just f prime. Like that's all I can do right now. That's the second thing times the derivative of the first thing. Plus the first thing, which is f of x. Times the derivative of the second thing, which is g prime of x. Close bracket. And then you probably won't write this stuff. I don't know, some of you are more about writing your work out than others. But I'm just going to put a 2 in front of this. So that's g of 2 times f prime of 2 plus f of 2 times g prime of 2. And then I'm just going to read those off the So I think it's possible to look and be like, oh, g of x, x is 2, just look at the table. I think this stuff makes you less likely to make mistakes, but then it also takes a little longer, so it's like the balance you have to decide between. So g of 2, so I'm only looking at that row right now. G of 2 is negative 1, f prime of 2 is negative 2, f of 2 is 4, and g prime of 2 is 2. And then, negative 1 to that's positive 2 plus 8, so that's 10 times that 3 out there is 30. But legitimately, if you are at the gateway and you leave it there, that's not a wrong answer. It's not an incomplete answer. All that's left is the 4 main operations. You can stop. You're going to see so many people get to here and have it right, and they'll end up with some computational mistake here and get like 28 or whatever. Then I got to mark it wrong. So there's no advantage to continuing once you get to that step. Try 5. Rewrite it if you want. So look at how I wrote it. Look up. If you don't, don't. So I'm just pulling out like there's 1/2 there. And if I pull it out in front, now it's not a fraction anymore, which makes it easier. So I don't know if this is like obvious or not, but that's your 1, that's your 2, that's your 2 things that are being. It's definitely tough though. Yeah, it's not just So your derivative is the second thing. So you're just rewriting 3 minus g of x times the derivative of the first thing. So you gotta take the derivative of 1/2 of x. So the constant in front drops down. The derivative of fx is f prime of x. And then the derivative of that plus 2 is nothing. So that's my second thing, and that's my derivative of my first thing. Plus the first thing times the derivative of the second thing. Be careful here. that's like the product rule step or the question on there. I have to put this here. And then you're going to plug in everything. So 3 minus, now we're doing -5. 1/2 f prime of -5. Plus, so now we have 1/2 f of -5. And negative g prime of -5. I step back and look at it. For a second, I imagine like I'm walking in from like a geometry class. It just looks overwhelming, impressive, scary. Those things. So then I'm gonna plug in. I hope it's not. That's not my point. But g of -5 is -2. F prime of -5 is 4. F of -5 is 3. And then g prime of -5 is 5. But I want the negative version of that. Like, I have no interest in calculating that out, do you? Obviously, there's no advantage to continue. Addition, subtraction, division, multiplication, that's all that's left. Question on that. Alright, jump to like the practice, the test problems at the back of the packet. Like 16. Let's do 16. So I see right away what is the equation of the tangent line. So I'm just going to put my kind of base formula here. I'm going to start filling in what I can. So this is the point that we're working with. So that's 2, 7. So 2 goes here, and 7 goes there. And then it's very tempting, and they're going to put it as a distractor. It's not either one of those. We could thought, like, put the slope here. So it's tempting to be like, well, that's the derivative, that's the slope, I'm going to put it here. They're not asking for the equation of the tangent line to F. They're asking for the equation of the tangent line to G. So I've got to find the slope of this. So how do we find the slope in calculus? Take the derivative, and then we're going to plug in. So why is this in this section? Because that's a product. X squared is a function of x, f of x is a function of x, so we got to do product rules. So that's a little goofy to people at the first time they see it. So that looks like g prime of x. So that's my 1. That's my 2. That's x squared. I just like circled it over it. So 2d1 is f of x times, what's the derivative of the first thing? 2x. Plus 1d2. First thing is x squared. What's the derivative of the second thing? F prime of x. Now, we want the slope when x equals 2. So I'm going to do f of 2 times 2 times 2. So that x goes in for all the x's, like whether it's an f of x or like it's just a straight up x. 2 squared and then f prime of 2. And then I can use my information to plug all that stuff in. So f of 2 is right there, that's 7. 2 times 2 is 4. 2 squared gives me 4. And then f prime of 2, they told me that as well, that's -2. that guy off. So there's really going to be a 20 right here. And it ends up being that. Because if I just took that 7 and moved it to the other side, you get y minus 7 on the left. But the point I'm trying to make is you can do a product rule with something like this, even where it doesn't necessarily look like it. So that happens in this one, you get the 4x and the fx. I think it happens in the next two also, if I'm remembering right. So that's f times g, you're going to do a product rule there. Oh, crap. Dang it. So I would have ended up wrong, wouldn't I? So 2, 20. So that, we're finding the tangent line at g. So that's supposed to be g of 2, not f of 2. My bad. I just put 7 there the first time, but that's the y value of f. We're supposed to use the y value of g. So plug 2 into that. So g of 2 is 2 squared times f of 2. 2 squared is 4. F of 2 they gave me 7. And so it's actually this one, 28. Does that make sense when I screw it up? I apologize for that. Hopefully it makes sense now. That will not be the last time you heard. I make mistakes a lot. Please, we're not official. Alright, I'm gonna let you work. Finish that whole section. Let me know what I can help with. Tomorrow's motion. So we're doing division tomorrow. And then I think we're gonna